starting on section 2.4, which is average rate of change of a function. So this is as you go from A to B. Okay, as you go from A to B, the net change is f of B minus f of A. The average rate of change is f of B minus f of A over B minus A. Okay, so an example that kind of, this is an example that kind of leads into this. Number one, if you travel 400 miles in 4 hours, then your average speed for this trip is, okay, so is in miles per hour. So you want to take the number of miles and you want to divide that by the number of hours, which is, there's 4 hours, so you're going to put a 4 there, and then this ends up being 100 miles per hour is your average speed. Okay, so in this case, your independent variable is hours, of which there's 4 of them that went by, and then your dependent variable is the number of miles that you travel, which is 400. Okay, number 2, the average rate of change of a function f between x equals a and x equals b is, it's given by this formula here, so f of b minus f of a over b minus a. Okay, so that's what that one is. So that's basically what we're trying to say today. Let's go on to the next exercise, number 3. The average rate of change of a function f of x between x equals 4 and x equals 7 is, okay, so in this case, a is 4 and b is 7. Now you take the second number and you subtract the first number from it. That's what's in the denominator. The numerator is going to be f of b minus f of a, but that's b is 7 and a is 4, so it's that there, except that's a minus, not an equal sign. And then f of 7, so here's f of x is x squared, so this is 7 squared minus 4 squared. I guess when you do this, I should put parentheses around it. So that's 49 minus 16. So I'm going to go ahead and put 49 minus 16 in there. And 49 minus 16 is 33. And then this piece right here is 3. Okay, so we have 49 over this 3. No, not 49. What am I thinking? 33. 33 over 3, which is 11. So that's 11 goes there. Okay, number 4. This is kind of giving you an idea of what's going on. Okay, so let me just draw like a picture of a function here. Let's say we have that function right there. And here we have a, and there you have b. Okay, so what happens is when we're at a, this is our y value, and when we're at b, this is our y value. This height above the x-axis is our y value. Okay, now if you go back to the distance between 2 points, okay, that is y2 minus y1. No, not the distance. Not the distance. Okay, now I lost my, okay, there. Okay. What I meant to say was the slope of the line segment. All over x2 minus x1. So it's y2 minus y1 all over x2 minus x1. Whoa. Okay, that just erased everything. No, dang it. Oh, this is a disaster. Okay, so this was what? This was 49 minus 16, and this is
11.
And then I have this. I don't know how that happened. This is disaster. Okay, so then I had this curve like this, and I said that's A, and then we have and then we have B over here. Okay, so there's those 2 points there. Okay, and then I said the slope between 2 points is y2 minus y1 over x2 minus x1. Okay. Something is weird. It's not giving me the save. Hold on a second. Something is messed up here. Let me. Dang. Let me close this. Okay, let me just save this. There we go. That's better. Okay. So the slope is between 2 points is this. Now, if this is the graph of y equals f of x, then the coordinates of this point are a, comma f of a, and the coordinates of this point are b, comma f of b. Okay, that's just how it works. So that's how you graph points on the graph. You plug the a in to your f, or whatever f is. You plug an a in there, and then you plug a b in, and you plug an a in, and then your point on the graph is going to be a, comma f of a. That's going to be the coordinates, and then the coordinates corresponding to this point are going to be b, comma f of b. Now the slope of the line segment that joins these 2 points is this. This line is called the secant line. Okay, it's called the secant line for some reason. Okay, the average rate of change. Okay, so the average rate of change, and this is how you find the slope in general. Okay, now part B, the average rate of change of the linear function between any points that's going to be 6. Okay, because no matter what, if you have 2 points on this line right here, on the line y equals 6x plus 4, then the slope of the line segment triangle, or the line segment triangle is just this line, and this line has slope 6. Okay, so basically, and the average rate of change is the slope of the secant line. Okay, so that's where that comes from. Now, let me just complete that idea right here, right before I got confused. This is f of b minus f of a. That's y2 minus y1 over b minus a. Okay, so that's how they come up with the formula. Okay. So number 5. Determine the net change between the indicated points on the graph. So there's this point and that point. And here, the y value was 5 to start out with, but then the y value went down to 2 to end up with. So the net change is -3. Okay, so that's 2 minus 5, or -3. Okay, or f of 5 minus f of 1, which was 2 minus 5, or negative 3. Okay, the average rate of change is you just take the net change, which is this negative 3, and you divide that by the second point, the x value of the second point minus x value of the first point. Okay, so that's going to be negative 3/4. Okay, let's go to the next exercise. So number 6, we have this function here, h of t equals 2t squared minus t. And we want to find the net change and the average rate of change between t equals 4 and t equals 6. Okay, so again, a is going to be 4 and b is going to be 6 in this case. So the net change is f of b minus f of a. So in this case, it's h of 6 minus h of 4, or h of 6 would be plug in a 6 into here. 2 times 6 squared minus 6 minus, and then plug in h of 4 in. Plug a 4 in there, so that's 4 squared minus 4. And let's see, this is 2 times 36, that's going to be 72 minus 6. And then this is 16 times 2, that's, I'll put these back. That's 32 minus 4. So 72 minus 6 is 66, and then this one is 32 minus 4 is 28. So I get 38 as the answer. Okay, so that's the net change. For the average rate of change, the average rate of change would be this f of, not f, we're going to change it to h's. H of b minus h of a over b minus a. So we know that that one's 38, and then we know that the numerator is 38 already from here. And the denominator, that's going to be 6 minus 4. Which turns out to be 19. Okay, so that's your average rate of change. Okay, again, if there's any questions, just let me know. So the next one is 2t squared. And we're supposed to find the net change and average rate of change between these two numbers. So this is a little bit trickier because the second one is kind of has some variableness to it. The first one is 3. The second one is 3 plus h. Okay, so again, that's our a. And then b is 3 plus h. Okay. So the net rate of change will be f of the second one minus f of the first one. So that's 2 times 3 plus h squared. So this 3 plus h goes in place of the t, minus f minus 2 times 3 squared. Okay, so if you take 3 plus h squared, now for 3 plus h squared, if you know the formula, great. If not, then do this. That's just 3 plus h times itself, and then just use the FOIL method, okay? So the first ones are going to be 9. So 3 times 3 is 9. Then 3 times h is 3h, and then this in the inside is also 3h, so that's plus 6h. And then the last ones are h times h, that's h squared. And then this is 9 times 2, that's 18. Okay, distributing the 2, you get 18 plus 12h plus 2h squared. That's distributing a 2 to each of these terms here. Okay, this is my favorite part, and that is that these 18s cancel with each other. Okay, so the net rate of change is going to be 12h plus 2h squared. Okay, and then average rate of change that's going to be f of 3 plus h minus f of 3 all over 3 plus h minus 3. Okay, so this is b minus a here. This is f of b minus f of a. Okay, we already know that the numerator is just this. But, yeah, it's just that. The denominator, these 3's are going to cancel. And you're just left with an h. Okay, you have to be a little bit careful here. Factor an h out of the numerator first. Then reduce these to 1, and your answer is 12 plus 2h. Okay, from grading Math 110 students' exams, this is one of the things that they have a lot of trouble with. So some students, not all, would have some trouble with doing this kind of thing. But it's just plugging in everything, and you got to keep everything straight, exactly what you're doing. And then when you're canceling stuff like this, make sure you take the h out of everything. Take the h out of this and take the h out of that, and you're good. Okay. Sometimes students will take just the h out of one of these and think that's good enough, but you got to take it out of everything. Okay. Number 8. Whoa, a fancy graph. Okay, the graph shows the depth of water in a reservoir. The water W, here's the W, and then here's the number, here's the days over a 1 year time, 1 year period, as a function of the number of the number of days. I don't think nobody's ever made this kind of spelling mistake before, have they? The number of days X since the beginning of the year. What was the average rate of change between 100 and 300? Okay, so we're looking at from here to here. What's the average rate of change? So there's a couple ways you can think of this. One of them, you could just use the formula. So A is 100 and B is 300. So you could just use that. So average rate of change, f of 300 minus f of 100 all over 300 minus 100. You could do that way. F of 300 is 25. F of 100 is 100. And then 300 minus 200 is, 300 minus 100 is 200. Okay, so you got negative 75 over 200, which slips to about negative 3/8. Okay, so that's the answer, negative 3/8 feet per day. So on average, it went down by 3/8 of a foot per day. But you know, like any given day, that probably wasn't the case, because like from 100 on up to here, 175 approximately, the reservoir was going up, the water level was going up, and then it would start going down until it got down to this really dangerously low level, and then people prayed for rain or something, and then it started going back up again. So, okay, so -3/8 was the average rate of change from there to there. The other way you can think about it is just look at these as coordinates of points. So this coordinate here is 300, 25. And this one is 100, 100. And then just find the slope of the line between those 2 points, which is going to work out to be this. So the numerator would be 25 minus 100, all over 300 minus 100. So it'll work out to be this. It'll work out to be the same thing in either case, of course. Number 9. We have a hot bowl of soup. It's left in a room. And the soup eventually cools down to room temperature. Okay, the temperature T of the soup is a function of time T. The table below gives the temperature in degrees Fahrenheit of a bowl of soup T minutes after it was set on the table. Okay, so find the average rate of change of the temperature of the soup over the first 20 minutes and over the next 20 minutes. So we're looking for the average rate of change of the soup. So the first 20 minutes would have been, from 0 up to 20. Okay. So in the beginning, at the starting point, the soup was 242 degrees Fahrenheit. After 20 minutes, it's 153 Fahrenheit. Okay, so to get this one, you take the last point, the last value, subtract the first value from it, and divide by 20. Let's see, 153 minus 242. Okay, so we have negative 89 over 20, which works out to be negative 4.45. So per minute, the soup on average went down 4.45 degrees Fahrenheit per minute on average. Okay, then for the second one, you got the next 20 minutes. So that's going from 20 to 40. Okay, so that's going to be the ending temperature minus the beginning temperature, all over the ending time minus the beginning time. Okay, so it's negative 56 over 20, which turns out to be negative 2.8. Okay, so for the next 20 minutes, the soup went down by an average of 2.8 degrees per minute. And so in the first 20 minutes, it was cooling off more quickly. And this goes along with Newton's law of cooling, which says that the rate that an object cools is proportional to the difference between the temperature of the object and the temperature of the surrounding medium. Okay, so in the beginning, since the difference between the temperature of the soup was hotter, so the difference between its temperature and the room's temperature was greater than when the soup was cooler. So then it cools down. It cooled down at a faster rate. Okay, but that's you really don't need to get into that. Just thought I would mention it. Okay, let's look at number 10. We have two speed skaters, A and B. Someone forgot to put an S on there. Okay, there we go. We have S and we have S. We have A and B. Okay, they're racing in a 500-meter event. The graph shows the distance that they traveled as a function of time from the start of the race. Okay, so that's 500 meters. So the first one to get to 500 meters or to get to this line is the winner, and that turned out to be B right there. So B is the first one to cover 500 meters. Okay, so part B, find the average speed during the first 10 seconds for each skater. Okay, that's from 0 to 10. Okay, so for skater A, okay, the first 10 seconds, skater A, they covered 200 meters. This would be 200. So the scale is 100, 200, 300, 400, 500. So they covered 200 meters in 10 seconds. So that's 20. Okay, so there are 20 meters per second. Skater B, they only covered 100 meters in the first 10 seconds. So they're 10. Okay, now the last 15 seconds. Okay, so the last 15 seconds for A, this is A's end of the race right here. Their last 15 seconds would have been this interval from here to here. And when they ended it, they were at 500 meters. When they started the last 15 seconds, they were at 400 meters already. And that's divided by 15, of course. So you have 100 divided by 15. Which is 6.66. So just a bunch of repeating sixes, right? But they're supposed to round it to the nearest whole number. So 7. Okay, 7 meters per second for the last 15 seconds of their part of the race. Okay, for B, they ended the race right here. So the last 15 seconds for B would be this interval here. So from there to there. Of course, they ended at 500 meters. And when their last 15 seconds began, they had only covered 200 meters. Okay, and of course, 15 seconds went by. So I guess you could take this and subtract that from it, but since we said it's the last 15 seconds, then it's just going to be 15. So that's 300 divided by 15, which is 20.